G'day guys, you're back with MiracleMAX. Welcome. Today we're on location having a look at a washing machine that will not go. The old mobile repairs, I remember them well. Believe it or not, I was a mobile mechanic for over 8 years. They were hard times. What do you want about, fella? This is a washing machine, not a car. Psh, let's get into it. If we open the door, you can see the model number inside. It's VHD 8144D, and of course it's an Australian model. So what's wrong with the beast? Now this customer had the power point turned off, but it was still attached to the wall. I find that quite dangerous because it's easy for someone to come along and turn something on and you're unaware of it. So you know my rule. Leave the PowerPoint visual in front of you so that you can see that it's totally disconnected and you are safe to work on it. Well, before I tell you anything about it, you can see that the customers had the back pulled off of it and given me a bit of a heads up of what was actually wrong with it. The main problem is that you can hear a humming when you first start it, but the thing will not rotate. Now what do I say before we start diagnosis? We'll obviously have a very, very, very good visual. Now what do you notice when we look there? Have a look at all this soot. Now that is electrical soot. It's not from a smoky chimney, it's not from, you know, fire burning or anything like that. And it's interesting, it's in this particular area, but if we have a closer look still, I'll just zoom in for you. Here's the motor to the left, and if we have a look over here, you can see that this is the startup capacitor. Now have a look at this one here, this terminal here. It's black as, isn't it? She's had the backside blown out of the thing. Could that be the problem? Well, there's one way that we can test and see if the capacitor is the main fault at this stage. Further to my diagnostic step of a good visual. Now, as I mentioned, there's soot absolutely everywhere and it's massive in this area, but it's also down this area. Now, the plate that came off the back tells a little story as well. You can see here, it shows up on camera quite clearly, I think. We can see a line that comes up through here, then we've got our big circle that goes right around the top here. Now this may be the point of origin, just like a fire, and it looks like it started here and then accentuated over to here. Now if the motor was spinning, it would circulate all that soot, wouldn't it? But this point of origin is what I'm referring to. Where does that come from? Well, if we just sneak across here, you can clearly see that here is our point of origin. It's gone up here and then into that circular motion because of the fan spreading it everywhere. So I believe that this is our point of origin where the fault actually lay. So the more I look at this, it may not be the startup capacitor, that little item that we're looking at. I believe it might actually be the heating element. There's no voltage there, I've checked. It has a resistance between these 2 points here and here, which you would expect from a heater element. It's got an earth on it, it's got a sense wire as well, temperature sensor probably. So yeah, it may not be the capacitor there, it may actually be the heating element. Generally speaking, one way to figure out if the capacitor is faulty is by spinning the motor by hand. Now the capacitor acts as like a little storage device for extra voltage to get the motor up and running. There's a lot of mechanical resistance that it has to overcome, and what it does is basically give you extra voltage to spin the thing up. But you can do it by hand. So what I did was I spun this drum up as fast as I could, and in theory, once the belt was attached, of course, the motor then should have enough power to kick in and take over the rotation. It didn't do that, so that suggests to me that it's not a capacitor, and that's why I'm starting to search at the engine or the motor at this point in time. Sorry, working in automotive, I'll get confused with motors and engines. My bad. Now that I've got my head on straight and realised that that was not a capacitor but a heating element, and that it's in working order, where is all this black stuff coming from? It looks like it's had an explosion at some point, but look, I don't think it is. You know what I reckon it is? I reckon that there is carbon. Where are we going to find carbon, guys? DC motor. Hello? DC motor. Brushes. Let's pull that out and have a look at it. So this fella rotates around and around. That's the actual drum, that's the agitator, being driven by this motor at a reasonable speed, probably about 1400 RPM according to the specs on the front there. It's driven by this belt. This goes on here, this goes on the drum like so. Now, as this rotates, this fella here rotates. Now, what's this look like? Well, it looks like a fan, doesn't it? If there's any carbon dust that's coming across here, hits the back plate, goes woof, gets sucked into this, and then makes this huge black area. In fact, now that I look at it, I can see black over here as well, and black over here as well. This is a massive, massive fan, and that in turn is actually drawing in this carbon to draw it over here. A bit tricksy in my books because it was a bit confusing to start with. Let's pop this motor off and check it out. You know, let's start with the basics as the channel suggests. Let's make this complex into something simple. Now this is just a normal DC brushed motor, as you can see. I've pulled the motor off to one side just to gain access to it. Sorry about the filming, just holding the camera at the moment. Now, as we can see over here, we have, I'll explain it to you in detail later, the little commutator, fat finger Max, in we go, commutator there. Brushes, where's the finger there, Max? There we go, there's a brush, doot, doot, doot. And of course that wiring, we can see, goes up here into this connector. So there should be continuity between this point, that one there, and of course on the other side, which will come up and join this connector here. Now I've checked with my multimeter and I couldn't actually find any continuity. I'll double check so I don't eat my words, but there should be continuity between the two brush packs. Okay, customer's been distracting me in the background, but as you can see I've got my multimeter hooked up. I'm just holding this so you guys can see I'm on either side of the brush pack there and there, and this is what my multimeter is reading. That's insane measurement there, isn't it? It doesn't make any sense whatsoever. So it's most likely brush pack is not connecting against the armature or the commutator. So we'll pull the brushes out, have a look at them. And of course, whenever you're working with wiring, etc., make sure you take a photo or two so that way you know what you're looking at in the future when you put the thing back together. Okie dokie. So this is the back of the motor I've got off now, of course, and this is our brush packs here and here. They're kind of weird. I haven't seen them like this before. They're actually angled going onto the armature itself. Generally they're, you know, heads on, but these are offset for some reason. So I'll pop them off and we'll have a look at them next. Of course, then we need to check the armature and make sure that the wiring hasn't burnt out or shorted, or that the commutator is in good condition as well. So brushes have been taken out, and yes, they are way past their abuse by date. Check it out, there's nothing left. No spring tension, no nada. If there's no brush material left, and of course the spring, there's a spring in the back, you see them in there, little spring. There's nothing to push against the commutator, which is this fella here. I'll explain a little more shortly, which is part of the commutator up and down here. Now you can see it looks like it's been arcing, looks a bit dodgy. It should clean up, not too bad, with a bit of sandpaper, which in theory you're not meant to do, but hey, you do what you do. And that should in fact be okay. So I believe that our main issue, our problem, is just worn out brushes. And this is passed just out of warranty, of course, typical. They're making stuff nowadays so that you know, it'll only last just out of warranty, and then you've got to go and buy a new one. What do they call it? Built-in redundancy. Pretty damn dodgy, hey? So now we need to check the commutator here, and as well as the armature. The commutator is basically a flat bit for the brushes to rub against. Then the armature is a soft iron core, which in turn has wiring wrapped around it, and then the other end comes out the back end here, which is what the other brush rubs up against. So basically we've got two brushes sitting against here, and an armature with a connector this side, goes through the wiring and then comes out that side, out to the other brush here. So what we need to do is check, have a look at our multimeter here, try and get me wiring out the road, and we need to check and make sure firstly that we don't have any connection between a commutator and the earth, which is all good, we don't. And then we need to make sure that we have continuity between those points and make sure that there's no dead spots in there. And so I'll go around there shortly and check them all for you, but it looks okay to me. They should be fairly consistent too. What have we got? 1.8, 1.8, etc, etc. So we just go round and around and check them individually and make sure that they are fairly consistent. If there's one that's dropped out, then you'll know that that's a problem. But yeah, looks okay. So most likely set of brushes. So you can see that the commutator is in a lot better condition than it was before. She's nice, mate. And all I've done is use a bit of sandpaper, just a bit of, I don't know, what's that, 240, something like that I suppose. And in actual fact I was surprised how good a condition it's in. I thought how it was before, it was pretty knackered, but in actual fact it's come up sweet. So, yep, just a brush pack. And the problem with the brush pack itself is they may be a little bit difficult to actually purchase. But I've found a Samsung one that seems to be very, very similar. I'll contact the seller and get them to do some measurements, but visually it looks identical, so and quite a lot cheaper, and it's here in Australia. I don't have to send over to UK where most of these particular ones for the Hoovers seem to be located. But hey, if I can get it locally at a reasonable price, that's where I'm going. You can see I've got the new brushes here. They came in the other day. I think they're off a Samsung or something, but I just did a visual and a visual check and made sure that all the measurements were okay. Now, one of the major problems, of course, if we have a look at it, you can see that the angle of the brush is like this. If we have a look at this one, I'll just get rid of that holdy down device. Oop, there we go. You can see that the brush is going the opposite direction. So, I think it just needs a little bit of attention, a bit of grief given on the bench grinder, and I think that'll sort out the issue. So that's what I'll do. Yep, looks all okay. Everything else measures okay. It's just this angle is incorrect. So I'll sort that out before we head off on location. So I'm back here on location in a tin shed on a 33-degree day. Sweating like a schmitzver. That's got nothing on me at the moment. I feel like I'm leaking more than the Titanic. Anyway, best thing I can do is get into this, get it fixed, and then get out of here. So I've got my brush packs. They need to be reassembled onto the motor. Let's start with that. I can't remember if I told you before, but this is classified as a universal motor. It's a series wound motor. What that means is we have a wire coming from here, our connector, that will go through one side of our field coil here. Then it will go through a brush, come out the other side of the brush, go through the other field winding, and then back to our connector over here, series wound motor. So when I tested it before, I had no continuity whatsoever. What was the reason? Remember, those brushes were worn out. So the old brushes are here. As you can see, there's no brush contact left on them whatsoever, no carbon brush. It's totally had it. When we compare it to our new one, you can see the distance between the two. A lot more brush contact, and of course spring tension on it as well. So in other words, the reason that I had no continuity or resistance when I checked it was because this was not touching against my commutator here, and therefore not allowing the complete circuit, therefore the thing wouldn't work. So now when I fit these, they should have heaps of tension. Then I should be able to check at 2 points here and here. Then I should get a measurement of my field coil as well as my armature. I've now got both brush packs mounted, as you can see. The length of the carbon brushes, the difference between the old and new was incredible. So what we need to do now is prove the integrity of this circuit, or the entire circuit, and that is done via this connector here. The grey wire and also the red wire are the end of these two circuits, I guess you could say. So if we get our multimeter, hook it up for your benefit, possibly. Let's have a look. There we go, as long as you can see it. So the bottom one I think was grey, and this one up here should be red. So we should have continuity. We've got about 1.2, which is consistent with the thickness of this wire and the length of it as well. So I can pop him back in, and hopefully that's got it all sorted. Okay, I've got it back together. We've got some water in there, and it's doing what's called a sense cycle at the moment. It's trying to figure out how much water, how much load is in there, and it's just going backwards and forwards, as you can see. So yeah, motor's working okay. It probably needs a load put in there properly. We've got some water running through it, but we probably need a load in there to determine if it's going to run through its full cycle correctly. But the major issue, of course, was the brushes down here at the motor, and the motor's working efficiently now. So the owner said that it's a lot quieter than it used to be as well. Of course, when the brushes wear out, they start to arc across the commutator, and it gets quite noisy. So yep, this should do them another 6 years or so, hopefully. But yeah, she's up and running, all good. Time to put the back on and put it back into place. Well, there's another successful repair, guys. The old washing machine's up and running again. Clothes can be washed. I tell you what, I'm glad this is finished so I can get out of the shed into the air-conditioned comfort of the house. So I hope you enjoyed this video, guys. I've learned something, as I always say. If you haven't subscribed to my channel, please do. Give it a like and feel free to comment down below. Don't forget about that notification bell either. Give it a good so next time you don't miss out on any future videos. So until next time, guys, this is MiracleMAX signing off. I will catch you later.